This is a draft, and don't know if it will see the light of day or not. So one of the demos in the notes is converting 37, the decimal 37, to binary. And one of the things, I'm old. In the old days, we had this thing called long division. And so if we were dividing 2 into 37, 2 goes into 3 one time. 1 times 2 is 2. Remainder of that is 1. We bring down the 7. 2 goes into 17 8 times. 2 times 8 is 16. And the remainder of this, so 2 goes into 37 18 times, and a remainder of 1. What the author refers to as being the upside down division is just coming up with this piece right here. So 2 goes into 3 one time. 1 times 2 is 2, so there's the 1 left over. 2 into 17 is 8 times, and then there would be a remainder of 1. So with the upside down division, we're saving, in a sense, all this room, but we're coming up with the same thing. So the idea of then going to binary is we keep repeatedly dividing by 2 and keeping track. That's supposed to be a 2 going into. So 2 goes into 18 9 times, and there's no remainder. 2 goes into 9 4 times, and the remainder is 1. 2 goes into 4 2 times, and there's no remainder. 2 goes into 2 1 time, and there's no remainder. 2 goes into 1 0 times, and the remainder is 1. So the idea in terms of the keep dividing by 2 part, we keep doing it until finally we get the results of the division as being 0. The taking the remainders backwards means taking them in this order. So 1 0 0. So going in this order: 1 0 0, 1 0 1, 1 0 1, and that would be the binary equivalent of 37. If we were to check that, so actually let me just rewrite this a little bit wider apart. Okay, so 2 to the 0. So starting from the right-hand side in terms of the powers of 2, we'll always begin from the right-hand side, 2 to the 0, 2 to the 1. And I'm just going to put them just so we don't, forget them. You don't want to, skip anything. 2 to the 3, 2 to the 4, 2 to the 5. Okay, so then for figuring out then the decimal equivalent of this, we only need to do it for the ones that we have the 1 for. Well, 2 to the 5, and as you work with the powers of 2 for a while, you'll soon get quick with that. That's 32. 2 squared is 4. And anything to the 0 is 1. And so that 2 to the 0 is 1. So 32 plus 4 is 36 plus 1 is 37. And so that is just checking that this number that we received is the binary equivalent of 37. So the slides from the author for Irvine Chapter 1 show that the picture that I have accompanied with it, this is sort of like going through how we got to the picture at that point. Okay, pause for a second. Okay, so the other method that was shown is what's known as the largest power of 2 method. So if we're dealing with 37, then we figure out what is the largest power of 2 that's less than it. And if we start from the right-hand side, right, 2 to the 0, that's 1. 2 to the 1 is 2. Okay, well, it is less. 2 to the 2 is 4. It's less. We want to find the largest one. I'm sorry. I may have misspoke. I'm sorry. I meant 2 to the 2 is 4. Um, 4, which is less than that. 2 to the 3 is 8, which is less. 2 to the 4 is 16, which is less. 2 to the 5 is 32, that's a 5, which is less. But if I did 2 to the 6, that would be 64. And so 64 is not less than or equal to 37, but the 32 is. So what we can do is, so we found the largest power of 2 that's less than or equal to this. We put a 1 in its place. So now we have a 1 in the 2 to the 5 place. Since we're, whoops, sorry. Since we're, we have a 1 in the 32 place, we'll subtract 32. And we end up with 5. So now this one's 16. 16 is not less than or equal to 5, so we have nothing here. This is the 8. 8 is not less than or equal to 5, so there's nothing here. This one, 2 squared, is 4. 4 is less than or equal to 5, so we'll have a 1 here. So we put 1 in the 4's position. Oh, God. Jeez. We subtract 4. We have 1. Well, the 2 is not less than or equal to 1, so we have a 0 here. And this 2 to the 0, which is 1, 1 is less than or equal to 1, so we have our 1 here. And then we subtract our 1, and we have 0. And so this is 2 different ways to get up with to the same number. So here we had 1, 0, 0, 1, 0, 1, 1, 0, 0, 1, 0, 1. This one we did the upside down division and got our remainders backwards. This one we just kept, we kept finding the largest power of 2 and then subtracting from it. If you were, well, if we were in the classroom and I had a closed note, closed book, no electronic device test, then either of these two methods are what you could use to take that decimal number and to come up with the binary number. And so either direction, either one of these methods are the ones that you can use. You may have seen one of them before and not seen the other. If you've seen one but not the other, try both methods and see which one you like. If you've never done either before, try both and see which one you like. And some people gravitate to this method. Some people gravitate to this method. I'm just trying to show both. The one other thing that I did point out previously, and we'll use this as a way to check our work, and that is, now remember the calculator that's in Windows? Normally when we're in the calculator in Windows, it comes up here in standard mode. There is the, scientific mode, but in the programmer mode, then that's where we can enter in, so in this case here we're in decimal format, we can enter in the 37 and it actually will show us the underlying binary. Now it's showing leading zeros because it's showing it in terms of multiples of 2, and in terms of powers of 2 in terms of number of bits, but the 1 0, the 1 0, 0 1 0 1, 0 1 0 1, it's just a way that we can just double check our work. And then going the opposite way, So if I just kind of clear this out, and if we go into binary mode, so 1, 0, 0, 1, 0, 1, I just entered in the binary number, and then there's the decimal equivalent of it. So again, I'm showing this as a way that you can sort of verify the numbers. What we'll see in the assembly, when we do a dump regs, we'll get it in hex, and what we may need to do is then put in the hex and then go back and then you figure out what the underlying decimal is. But for this little video right here, I just wanted to go through, I guess technically 3 ways to convert the 37 to binary. One is what I call the upside down long division method. The other one, which is the largest power of 2. And the third one, which is have the computer figured out. Which actually, no, that was back when we were in the decimal mode. Put in the decimal mode, had the computer figured out. Okay, so that's it for this video showing just 37 going to binary.